Good morning, everyone. My name is Magar MH, Assistant Professor from GMD Arts, BW Commerce and Science College, Sinnar, Nasik. Today, I have discussed about third chapter, Quality of Irrigation of Water from TYBSc, Lecture 2nd. The point is related problems in public health, environment and agriculture. In this point, including sub-points, first, drinking water standards. In drinking water standards for the domestic use in India, agencies like the Indian Council of Medical Research, Bureau of India Standard and Ministry of Work and Housing have formulated certain drinking water standards which are being followed by different authorities. The World Health Organization, that means WHO, has also laid down drinking water standards, in including the characteristics. First, physiochemical standards. Second, bacteriological standards. We know that students in physiochemical standards including turbidity, color, taste and odor, pH, total solid and total hardness and other dissolved inorganic impurities etc. In second, bacteriological standard including coliform count, E. coli count and other microorganisms. Second point is irrigation water standards. In irrigation water standard, in agriculture chemistry, we are interested to study the quality of irrigation water and irrigation water standards with regards to the quality of water for irrigation for variety of crops. The major parameters of concern are salinity, potentiality, toxic trace elements, and group of other miscellaneous problems. The presence of sodium is also an important parameter in irrigation water standard. Which factor is important? Sodium factor, sodium parameter is important for irrigation water standard. The excess quality of which can deteriorate of the soil. The high value of sodium may also damage the sensitive crop because of sodium phototoxicity. We know sodium is important for irrigation of water, but also in high concentration of sodium, it affects to crops. The salinity. The salinity means salt in soil or water reduces water availability to the crop to such an extent that the yield is affected. It is denoted by dissolved solid and conductivity of water. Water infiltration rate. Water infiltration rate means relatively high sodium or low calcium content of soil or water reduces the rate at which irrigation of water soil to such an extent that sufficient water cannot be infiltered to supply the crops from one irrigation to the next. In specific ion toxicity, the specific ion toxicity means certain ions like sodium, boron, chloride from the soil of water accumulate in the sensitive crop to concentration is high enough to causes the crop damage and reduce yield. We know that, for example, any substance are essential for crops, but it is high concentration are including they are affected on crops. Miscellaneous. In miscellaneous means excessive nutrients reduce yield or quality, unsightly deposit on fruits Fruits or foliage reduce marketability, excessive corrosion of equipment increases maintenance and repairs. Next, analysis of irrigation water. Analysis of irrigation water. For the for the analysis of water, we must know how to collect the irrigation water sample and sample collection procedure. That means um, that means वॉटर सॅम्पल कशा पद्धतीने कलेक्ट केलं जातं आणि त्याची प्रोसिजर काय हे तुम्हाला माहिती पाहिजे. त्याच्यात फर्स्ट पॉइंट कलेक्शन ऑफ रिप्रेझेंटेटिव्ह वॉटर सॅम्पल. सेकंड, इन जनरल वॉटर इज अनालाइज फॉर थ्री पर्पजेस. हाऊ मच पर्पजेस? थ्री पर्पजेस. Analyze in general water is analyzed for three purposes. First purpose is it's suitable for drinking, it's suitable for irrigation, its suitability of environment. We know जर वॉटर चांगली वॉटरमध्ये काही सबस्टन्स वगैरे असतील किंवा वॉटर इम्प्युअर असेल तर आपण ड्रिंक करणार का नाही, मग ते अनालिसिस करणं ते त्याच्यासाठीच अनालिस केलं जातं. आपण वॉटर पितो ते कशा पद्धतीचं आहे. त्याच्यानंतर इट्स सुटेबल फॉर इरिगेशन अँड इट्स सुटेबिलिटी फॉर एन्व्हायरमेंट. फर्स्ट, द कॉमन सॅम्पलिंग टूल अँड accessories are which accessories? The clean plastic or glass bottle of 500 ml or 1000 ml capacity. How much capacity? 500 ml or 1000 ml capacity. Second, cotton or nylon threads. Third, glass or plastic marking pencil. Fourth, water table recorder. These four are essential tools and accessories for common water sampling tools. A sample collection procedure for irrigation quality. The sample of irrigation water is collection in about 500 ml or 1000 ml plastic, glass or polythene bottles, which should be transparent. The container must be thoroughly cleaned before use and should be rinsed 3-4 times with the water from which sample is drawn. सॅम्पल टाकण्याच्या आधी ते किती 3 ते 4 वेळेस वॉटरने क्लीन करायला पाहिजे ते कंटेनर्स, तर तेव्हा ते युजफुल केले जातात. सेकंड पॉइंट, इफ द सोर्सेस ऑफ इरिगेशन वॉटर इज अ टँक, canal or river, the sample should be drawn either from a spot away from the side or from the middle stream. The tube well or hand pump is to be run out about 10 minutes. Prior to sampling and for open well, several buckets of water have to be thrown out first. About a half or liter of sample is quite sufficient. Next, the water sample after proper marking and labeling must be sent to the laboratory immediately for testing to avoid any change or deterioration. If a few days delay of analysis of water sample, then added 2-3 drops of toluene to prevent bacterial activity. Toluene are added because the bacterial activity. Generally, water sample is directly taken for analysis, but in some cases, little amount of sediment is present if it may be allowed to settle down, or in few cases, sorry, it become necessary to filter the water by Whatman filter paper number 1. All of you, we know that the Whatman filter paper number 1. We will use the practical session. This filter paper is used for testing purposes. Second, handling and preservation of water sample. The sample from the sampler should be transferred to well-rinsed, labeled and borosilicate glasses, polythene or polypropylene container. For the analysis of parameters like dissolved oxygen, oil, and gases, the use of glass bottle is necessary. Proper labeling should be made on each sample as follows. First is name and location of body of water. Water sampling date. Third, time of sampling. Fourth, depth of sampling for well and tube well water. After labeling, immediately the sample must be sent to the laboratory for analysis to avoid any change in its quality due to the chemical and microbial activity. Analysis of irrigation water. Water is analyzed to determine its quality. The analysis provides information on suitability of water for irrigation and suggests management practice to follow. The common determined substance including cations of Ca, Mg, Na, K and anions of sulfates, chlorides, carbonates and nitrates. Other substances such as Pa, E, Cu, Tb, Fe, Mn, Fe, zinc, etc. Dissolved gases like CO2, carbon dioxide and H2S are also reported. Quality of irrigation water. The turbidity, electrical conductivity, pH, hardness, specific gravity are determined to the quality of irrigation of water is generally expressed on the basis of relative concentration of sodium to other cations, total concentration of soluble salt. Third, bicarbonate content. Fourth, boron concentration. These are essential for determining the quality of irrigation of water. PH, turbidity, electrical conductivity, pH, hardness, specific gravity. The various units are used to express data obtained by chemical analysis of water. First type ppm. ppm means part per million. The part per million means one part of solute dissolved in 1 million part in 1 ppm. For example, 1 gram solute in 1 lakh gram per ml of water. 1 mg of solute in 1000 gram or 1 kg or 1 liter of water. This ppm is very small amount as compared to gram, milligram, kg. Second, milligram equivalent per liter. Milli equivalent of ions or compounds in 1 liter of water. Third, equivalent per million. EP, equivalent weight of iron or salt per million gram of water. Next, dissolved constituent and their function. They are divided into two classes. First, major constituent, second, minor constituent. In major constituents, including cations like Ca, Mg, Na, K and ions like carbonate, bicarbonate, sulfate, chlorides or nitrates. These all of you are explaining next lecture. Okay. Second point is minor constituents. In minor constituents, boron, silicon, nitrates, sulfides and chlorides are including. These all major and minor constituents are explaining next lecture. Okay. Thank you.